Attempt number 2 to record part 2 of building our catcher game. So with the intersection, we're going to be passing to our intersect function two objects, in this case the catcher and the drop. Later on we can make additional copies of this that may look for additional objects, so it accepts drop versus drop, or drop versus something else, or catcher versus something else. But in the beginning our game is we only have a catcher and a drop that we're going to be worrying about, so that's how we're going to do. Again, we calculate the distance between the two objects by passing in the x and y coordinates for each object, and then we compare that to the sum of their two radius values, but you could also think of that as half of their width. So we're comparing half of the width of each object to how far apart the objects are, and if that distance is less than the sum of their half widths, then we know the objects are intersecting. Otherwise, they are not. So we're able to implement this by putting it into our draw function. And we need to do it so that every frame, when we're updating our drops, that already gives us access to one of our particular drops. So we can work with it by just simply saying if, and this is, back to the question of what do we begin with? We begin with an if. So we're inside our game class here. So not in timer, drop, or catcher, but inside the game class, inside the draw function, inside our for loop that is cycling through all of the active drops. And after we've updated and displayed the drops, we can say if, and in this case, intersect, and now we have to pass to it our catcher and the current drop we're checking, so it'd be drops I. So we pass to it those two things, and then we say if that is true, then we want to do something, and that something we want to do is we want to tell our drops to be caught. Now the drops have a caught method, we just haven't put anything into it yet, so we'll figure that out in just a moment. So then you can say, not drops, but drops. Within the world of class-based coding, it's generally considered a good practice, you could kind of call it good manners, that when you are working with objects, ideally you are just accessing methods on those objects. You're not updating or changing the values of the objects themselves. That's why we say drop. We tell the drop to update, we tell the drop to display. In this case, we're going to tell the drop to be caught. And we let the drop worry about what does being caught actually mean. So we don't say, drop, I want you to stop moving and I want you to change your position and blah, blah, blah. We just say, drop, you're caught. And then the drop goes, okay, I know what to do. And then the drop's going to figure it out. So now we're going to tell the drop it's caught. Now if I go in my drop class, we'll see that there's a stubbed out method, caught, and it's waiting for something to happen. When the drops are caught, I want them to stop falling, and then I want them to position themselves into kind of a terminal place so that I know they're no longer part of the objects I'm trying to catch. When a drop is caught, we can just simply say speed y is equal to 0. Now if I just run it like this, we'll see every time I catch one, they're going to stop moving. So if I go ahead and run it, I have no error messages, that's good. When I catch them, we'll see how they freeze, and I can catch them when they're fast, when they're slow, and they freeze on screen. And you can see how when they hit me, they stop. So using that, we proved that it's possible to catch the drops. Now that the intersecting is working, and that we're able to stop objects when they fall on screen, so as we see them fall onto the screen, it would make more sense for the objects after they're caught not to stay parked there on screen, but to locate to a new position. What we want to do is also move them somewhere. So I can move them all to the bottom or all to the top. I'm going to just throw them at the bottom. No, yeah, sure. So if I say y equals height, once I catch it, they will drop mostly off screen. Once I catch them, we'll see how it pushes them all down to the bottom. I prefer to catch them and leave them on screen because that shows me that I know where they are, so that I know my code is doing something. If I make them appear off screen, which in the final production model, that's what we will do. When we do that, then we'll want to give them like a minus r value, like maybe like 10 times negative r, so we know they're way up off the top of the screen and we can't see them anymore. But right now if we say height, because our drops are just a circle drawing from their middle, that means half of their body will still be visible on screen. That's why they show up at the bottom of the window when I catch them. So when I catch them, we see where they're kind of sitting half underground. But I like to do it that way in the beginning to prove that something is occurring. If they just disappear, I'm not really sure have I taken care of them or not. Adding in a score to our game, this is where it gets interesting. We need some text that we can write on screen to keep track of that, so that we can have that score show up on screen. Right now we're throwing some text on screen where we're showing us the current time. So we have a text field and then it shows us the time. If I want to now also show the score, that means I'm going to need a way to keep track of the score. Keeping track of the score means I need a variable. That variable will be some type of a number. In this case, it would kind of make sense that my score is a integer, because if I'm keeping track of my score, I'm catching drops. Each drop then gives me 1 or 5 or 10. But they're whole numbers. It wouldn't make sense to make my score a float variable because I'm not going to have a fractional score. If your game mechanic gives you scores that aren't just whole numbers, then you would need to use a float. But I'll choose int. And I'm going to call it game score. It would make sense for my game score to start out as 0. So I start out my score at 0. So I now have a way to store my game score value. So this will just be a number, and then we will populate it every time I catch a drop. But first I want that game score to show up on screen. And we can do that by using an additional text statement and say score plus game score. And if I started at the same left value, but I'll drop it down a little bit, I'm just going to choose a random number of, say, 120. So if my time value is on screen at 100 y, I will put my score beneath it at 120. And I can tweak that value depending on if I choose a different font for my text, where we can set the fonts and do all of that. We can change the size of our text, but right now I'm just using the default text. But if I wanted to, I could certainly update it. And if we look at it on screen, we'll see that I have a score of 0, and my time is counting down. The timer is left over from last week. We haven't fully integrated that into the game yet. Now, if I want that score to change so that we can see my score updating, we have to figure out where that's going to go. adding to my game score will be in the intersection. So when that occurs, so if an intersect has occurred, game score plus plus. Now, if my game score goes up by 5 each time instead of 1, or goes up by 2, then we could certainly use a plus equals, not plus plus, but a plus equals, whatever value you want. But if you're going up by 1, you can make your code look fancy and just use the double plus, because that's what that's what the cool kids are doing. So it would just make sense to do that. But if you want to do plus equals and choose a different value because it's not 1, go nuts. If you want to say plus equals 1, go nuts. So every time I catch one, my game score should go up. If we look, hey look, I can catch them, and my game score is going up. Right now we have a quasi-working version of our game. Our timer counts down, our score goes up when we catch them. Now some of you are already asking about other variations to that, about avoidance, multiple objects, and things like that. Those are all possibilities and extensions that we can go into, but our core goal right now is to get the base mechanic down. Once we do that, we can update the artwork, we can update the gameplay, we can add in all these extra features, we can do all of that. But there's no point in doing any of that until we actually have a working product. So right now we have game 0 complete. This iteration is done. And what we're going to do then is work on now building the next version of it. So to that end, I am going to go into my folder, and I'm going to take my project and I'm going to duplicate that folder and change the name of that from game 0 to game 1, because this is now my next iteration. And I have to change my main game file's name to match that. So the game1.pde matches the game 1 folder. And then I can close all of those files that I'm working with. Now I'm going to open up my game 1. So game 1 is game 0, but it's a fresh start. The reason that we do it this way is, as we're working, we're going to break things. And it's really nice to have a version to go back to go, hey, look, my project actually used to work a while ago. So when it's broken, you can go back and make yourself feel better again about going, oh, look, see, it did actually work. I wasn't just having a hallucination or a dream. What we are going to do now is we are going to reorganize your code a little bit to make sense out of things, and we're going to have to add in some things that aren't currently there. We're going to change some other things around, and then once we do that, after we've gone through what seems messy, it will be much cleaner, and then you'll realize, okay, it's not so bad, but in the beginning it might get a little bit messy as we have to move things around. So what we are doing with this is we are creating the concept of what is called a state machine or a state system. So with our game, it's going to have a number of different states associated with it. And we can make as many or as few as we want. Currently our game has one state. I hit run, the thing runs. That's it. It doesn't do anything else, it just runs. We're going to modify it so that our game has a starting state where it shows you a starting screen that we will then have to click to get past, and then we can play our game, so we will have a play state or game state, and then we will have a win state and a lose state. And once we've managed to get those 4 states working properly, then we can start addressing the problem of, okay, now that I won, how can I go back and play again? Now that I lost, how can I go back and play again? And once we can do that, then we've opened it up for the concept of introducing in levels. So then we can think about tweaking our game code and programming to add levels to our game states if we so desire. You may decide that once through is enough, and you win, you lose. After that, you can start over. You don't get to keep advancing levels, because levels are really just a modified version of a win state. where the win state you don't ever win. All you do is keep having a pseudo win where then your level increases each time. So it's not quite the same thing. But we can look at that as a possibility as well. So we need to work our code a little bit so we start getting into our different states. Now, to that end, what is going to happen with that is we are going to have our states that we can work through. And with each one of these states, we're going to set different values with them. Now, inside programming languages, when we set up a state system, often what is used is a concept called a constant. Now, there are constants built into processing, but they're a little bit harder to access, and we're not going to work with them directly. So we're going to create pseudo constants. And a constant is then a set of it's a value that then theoretically never changes as your program runs. So it's a item that you set it at the beginning, and then it will remain the same the whole time through. But we are going to now create a variable, and it will be a string, and we will call it game state. Now our game state is going to have a few different possible values. Now the values that game state is going to have will be start, play, win, lose. Oh, but I want to refer to them and make them easier to see in my code by using all capitals. So if I use all capitals, it's going to make my code a little bit easier to see and reference. Just so it stays on screen along with the other items, I'm just going to add it here in my setup. And I can say game state is equal to start. So that now starts my game. Now it's possible in a more advanced version of this game state that we would have a loading state. If I needed to load sounds, if I needed to load images, bitmaps, and other artwork, I could have a loading state that then it shows the user, hey, we're loading content. Because when it's happening locally on your computer, it's near instantaneous. But if you're trying to go across a network connection, like on a website, it may not happen right away. And that means we need a loading state. Otherwise, the end user goes to play your game and it'll be like, what's going on? There's just a blank screen. But if you have a loading state, you can be providing feedback about what % is currently loaded, how much data is downloaded, so they have an idea of when they're going to actually be able to play. So we're going to start out and say start. There. So our game state is going to be start. And now inside my draw function, this is where I'm going to write out an if statement. So if my game state is equal to start, I want it to do something else. If game state is equal to play, else if game state is equal to win, else if game state is equal to lose. And I'm going to put one final else in, else if, and I'll say else, and then we'll say print line something went wrong with game state. So this if statement inside my draw function, right near the top, it says if my game state is start, do something else. If the game state is played, then we'll do something else. Else if my game state is win, do something else. Else if my game state is lose, do something else. And then I have my final. If game state is not equal to one of those 4 values, it's going to give me a message and say, oops, something went wrong with game state. And I'll just print it out in the console down at the bottom. And we're doing that so that we have some feedback for when it breaks. And this is useful because as we go to program this, we will sometimes find out that, oh, our game state is borked and it doesn't work. And we need a way to know that. Now you could have it set your fill color to red and you could draw a rectangle that's the size of the stage, so it just puts a big red rectangle on screen. So when you see a bright red rectangle fill your whole screen and nothing else, then you know that your game state is broken. And then you could write some text on it and other stuff. And so you could do more than just write out the message to the console, but you know, that's a good first step. So if my game state is start, what I want to do is I'm going to put a different background in so I can tell that I'm at a different place. And I like doing that in the beginning, just putting in a colored background and maybe some words on screen is a really easy way to know that your states are actually happening. And then we can work forward with that. So if my game state is start, then what I can do is say fill, and I'm just going to fill it with red. And then just draw a rectangle the size of the screen. And at this point, we could put some words on screen if we want to say, like, click to start or something to that effect. But even if I didn't, if I run my game now, just by putting a fill and the rec command in, what we should see is now the background is filled with red. Now the game is still running because I have not taken the rest of my game code and moved it anywhere else yet. So the game is still running. So with that, I think I need to move that over. And that will be, I'll have to put the game inside my play section right here. Because I forgot that was going to happen and was disappointed when my game just ran. So if I take all of my current game code right now, game code, and this is the part I warned you about where it could get messy. I'm going to cut that. Oh my gosh, my whole game just disappeared. My heartbeat's going a little bit faster. I'm starting to freak out. A bit of sweat on the brow. No, it's no big deal because all I did was cut it, so that means I can now just paste it. And now that it's pasted in, on inside processing, we can auto-format it. We've moved the game information to our play state. Our starting state starts out with our red screen of doom. So now what we need to do is add in an ability that when I'm on that screen, that we can now move or advance to or change our game state and move into play. So if we want to do that, we just need to figure out a way to go about doing it and perhaps provide some information to our end user of what they need to do. Because this is going to be, in the catcher game right now, a mouse-based game, because the catcher is updating based on the mouse position, asking for them to click on screen seems like a reasonable option. So if we ask the user to click on screen, then we can change our game state from start to play. The way we're going to do that is first put some niceties on screen, instructions. So if I set my fill color now to white, because the white text on red is better than black text on red. Now I can just do text. click to start game. At some point, you can worry about changing your font. You can change your position. You can change the size of the text. You can do all that fancy stuff. You can go read up in it in the help files about how you implement those as part of your project, and that's all good. You can use custom fonts. You can do all kinds of crazy things. But now if I run my project, let's see what I get. Comes up and it gives me some text and it says click to start game. So if I want to click to start my game with no typos on there, then what I will need to do is I will need to now make a way to do it. It's possible that we can build a section that is a button, but realistically, if the whole screen is clickable, it's probably going to be good enough. If we want to make a button, what we can do is we can compute the distance of the mouse from a predefined area where we may stick a graphic or a shape or something like that, and we can say, hey, what's the distance between the mouse and that? And if the distance is small enough, that means the mouse must be within that area. Oh, it's our intersect function. And if that's happening, then we can change our game state, or we can just say, hey, if the mouse is pressed, change the game state. It really is going to be, you can decide, well, first just make it so that if we press the mouse, it happens. Then we can look at making it a little bit more specific for it. So if I say, if mouse pressed is equal to true, so if the mouse is pressed, then I can change my game state to play. So currently, here's my screen. Now if I click the mouse, I should see my game state change to play, and the background will become white, and the objects will start falling, and now I have my catcher, and we've now managed to organize flow. So what the game state system allows us to do is to control the flow of what is happening at any given time. Now that we have two of our game states worked out, we need to figure out how we can get to our win and lose. So the conditions that are going to determine that we can win and lose are going to be either currently based on the timer. Timer runs down to 0, you lose the game. And winning means I have now successfully caught a certain number of objects. Probably going to need to modify the objects when they get caught so they don't just park on screen where I can get that infinite score thing, because it's kind of cheating. And when I catch an object, I'll want to, now that I know that catching is working, put them somewhere further off screen. To make things easy, I'm going to, on win and lose, just put in a colored background. And we'll just put in a solid colored background. So I'm going to copy paste what I did under my start with my fill and rect, and then just change the color appropriately. And I could put some text on screen if I really want, but right now that's going to be enough. And when I win the game, I'm going to put the color yellow on screen, because everyone, they say yellow is a happy color, so that makes sense. But if I lose the game, I want to put the color blue up, so it's our blue screen of death, going for the whole kind of what is supposed to not be part of the Windows operating system anymore. They've supposedly taken out the blue screen of death from it in Windows 8. So I can't speak with authority on that because my Windows 8 time is short, but it just dies without a blue screen of death. I've now set up my win and lose so that they will change colors on the background, but I just need to put into my coding what is going to make that happen. Since it's right up here on screen in front of me, I'm going to deal with the winning situation. Currently, when I intersect with an object, my game score goes up. Well, what that means is I just need to look for what value is going to determine that. When you are building your prototype and figuring out, if I have, say, 100 objects and I have to catch all 100 to consider that a win, probably don't want to, during the testing phase, force yourself to catch all 100 objects to win. 3 or 5 is probably adequate to go, hey, it works. Otherwise, you get really bored when you test it over and 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 over again. So if game score, I'm just going to say, is greater than or equal to 5, I can wait long enough to catch 5. Game state is going to be set equal to win. Now, the reason that I throw the greater than or equal to 5, I use that as a little bit of a kind of catch-all. If the program somehow hiccups that it registered, boom, 2 hits for whatever reason, I don't want it to go, oh, well, I was at 4 and now I'm at 6 and somehow I had a brain fart and didn't catch 5. This way it guarantees I'm going to, win. So while I'm scoring, if my score now hits that point, in this case I'll start out with 5. Eventually I may make it 10 or 50 or 100 or whatever the case is. Then we'll go with that. Now losing, well, before I add in anything else, a good practice is every time you add in one new feature, test it. If I add in, oh, I added in win, I add in lose, I add in this, I add in that, and then I hit run and it breaks, well, then what broke it? But I know if this works, then when I work on lose and it breaks, then I know where the breaking is happening. So it makes sense to only add one little thing at a time and then test your program. Test often. Okay, so now my game comes up. Click to start game. I click. 1, 2, 3, 4, 5. Hey, yellow is a happy color. I won. There's still no way to lose yet, but at least I proved that I can actually win the game, so that's pretty cool. So now we need to figure out losing. Adding in the ability to lose, or to change your game state to lose, is going to happen based on the timer. So currently, we say if the timer is finished and current time is greater than 0, blah, 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 blah. So at this point, when the timer runs out the next time, it won't start up again and it goes down to 0, because this says when the timer is finished. And I'm going to just modify my timer so it only runs for 5 seconds, because 10 is far too long to wait. And I'm going to just get rid of this momentarily. Don't follow, but just watch the result. And when I do that, that says, okay, click to start. We see 4, 3, 2, 1, 0, negatives. And I have to try not to win while I do this too. So we can see my time goes into negatives. So this says if timer is finished and the current time is greater than 0, starts over. Now we could do an else if, or for that matter I can just even do an if. It will bring me to the same result, but I could say if current time is equal to 0. My current time is equal to 0, game state is equal to lose. So this says if my current time is now hit 0, I ran out of time, then we're going to make our game state switch to lose and pull up the blue screen of death. So right now my timer, I will have 5 seconds on it. 3, 2, 1, 0. Oh, dead. Blue screen of death. We have a game state system. It starts, it plays, and then it has 2 possible outcomes, lose or win. Lose is accessed when the timer runs out. Win is accessed if the score beats the timer. Because if the score beats the timer doesn't get to run again, doesn't matter, so we can't lose. So we can win or we can lose, but we can't do both. So we've created that flow chart based on events. Time runs out, you lose. Score goes to the correct value, you win. The next item that we will look at adding into this at our next session will be how to make it possible to reset so that we can play the game again. And we'll figure out what that entails.